Hello and welcome to Cyber Skills Live. My name's Daniel and I'm a climate conscious engineer. You're joining Craig and I for this very special Cyber Skills Live. Now Craig and I love everything tech and data. And today you're going to be using data science skills to help fight climate change.
That's right, and today we're coming to you from Glasgow, the home of the COP26 climate conference. World leaders are coming together for important talks about the future of our planet. Thank you for joining us. We have groups joining us today from across the world and across Scotland as well. This is your chance to learn about data science skills and climate change in the classroom. You're about to get hands-on with data. So what is data? Well, data is information. It's things that we know. It's things like facts or numbers, things that we can measure. And data science is being able to collect that data, being able to understand it and use it to make decisions. We need more people who understand how to work with data and how to use it to make better decisions. But can we use data to save our planet?
We're in a climate emergency. To give us the best chances at reducing the impact of climate change, climate scientists have stated we need to secure global net zero by 2050 in order to keep the global temperature rise under 1.5 degrees. Now to do this, we need to accelerate the phase out of coal, we need to curtail deforestation, we need to reduce our usage of fossil fuel transport, and we need to encourage investment in renewables. That's what we're going to focus on today, renewable energy.
You'll use real-world data sets to create a proposal for a renewable energy system for your school. You'll need to work with energy usage data, geolocation data, satellite imagery and Earth observation data collected by NASA.
So, are you ready to use data to save our planet? Let's plug in the numbers and use data science to reduce your school's carbon footprint. Thanks for joining us. We're really excited about this one happening during COP26. So as world leaders, delegates and activists debate the future of our planet literally around the corner from us, you're going to be data scientists exploring how renewable energy can reduce your school's carbon footprint. What you need to do now, if you haven't already, is go to cyberskillslive.com and click Start the Live Lesson.
Yep, all you need to take part today is a web browser. So head to cyberskillslive.com and click Start the Live Lesson. So once you've gone to the website, it'll ask you to put your name in and put your first name in and choose your school or group from the list. And we're going to be tracking your progress and giving you hints and help along the way. So don't worry if you fall behind or you get stuck or you've never done anything like this before. Daniel and I will be able to help you catch up. So when you sign in, you're going to select your school name and you're going to put in your first name from the drop-down list. Now, Daniel, we know that there's hundreds of people joining today as well. So if you find on your school computer it's getting a bit slow, all you need to do is just wait 1 minute and then try again. But Daniel, there's already loads of people joining us right now.
Yeah, I can see lots of you already joining us. We're going to be following along with your progress, giving you hints, shout outs, and guiding you through plugging in the numbers. Speaking of shout outs, you're joining us from all over Scotland and further afield. So let's do a few shout outs to some of the schools that we've got taking part today. So first of all, I'd like to say a big hello to Balmildy Primary School, Birch Grove Primary School, and Clober Primary School. You're all joining us.
I can see, Daniel, we've got some more groups as well. We've got Opterader Community High School joining us. Thank you. Hello to Craighead Primary. Thanks for joining us. And Lairsland Primary as well. Thank you for joining us this afternoon too. Well, there's loads, Daniel.
There's loads.
There's loads
Milngavie Primary School. Thanks for joining and playing along. St Paul's Academy and Dundee, you're joining us too. Wollaston Primary School, I can see you're logging in. Brilliant. Well done.
This is really good, Daniel. I can see we've got like a real selection of people today right from across Scotland, because we've got Stowe Primary in the Scottish borders all the way to Skeld Primary in the Shetland Islands. So right across the country with us today, Daniel.
Yep, full spectrum. And we've got a few more schools as well, I just want to shout out. So we've got St Joseph's Primary, Carron Primary, Caskie-Berrin Primary, Borough Primary in Galashiels, Gowmuir Primary, and Wardy Primary School.
And Daniel, we also have some international participants as well, so not just Scotland. Hello to classes joining us today from Pakistan. Hello to you. Hello to classes joining in Sweden and Indonesia as well. Wow, that's quite a lot. So we'll have some more shout outs later as people work through the activity. Daniel, what should people be doing now?
Yeah, so in this interactive lesson, we're going to be using data to answer this question. How much energy could a solar panel on the roof of your school generate? And also, what impact would that have on your school's carbon footprint? Every school taking part today is going to have a slightly different answer. I reckon one of those schools in the borders will have quite a different answer to that school in Shetland, and that will be very different again to Indonesia. We're going to help you gather the data, we're going to help you analyze the data, and then you're going to do some calculations to come up with an answer to that question based on all the information specific to your school. So what you need to do is follow the instructions on your screen to start the investigation. Our virtual data scientist and climate activist, Sunny, she's going to guide you along the way.
And we want to see your results as you work through the activity. If you're an adult, you can tweet us at Digital World HQ or at data_schools, and you can use the hashtags DataSkillsLive and hashtag COP26. We love to see your messages, your photos, and the results of your calculations while you work through the numbers today. So thank you everyone for taking part. I can actually hear, I'm being told that we've got more people joining us right at the moment. So don't worry if you've just joined, we're just getting started now. You just need to head to cyberskillslive.com and click start the live lesson.
We've already started to collect data about you. So we can see your names and I can see your avatars as well. And I'm going to share with you what we can see. So this is our activity field. And this is where we can analyze all of the data that you're going to send to us. So hello to David at Aberdeen Grammar School. I can see we've got Oliver and Lauren playing from Birchgrove. You've just met Sunny.
Grace as well, and Ella, I saw you taking part too. Lewis from Lairdslin Primary as well. Sophia from Balmildy. Wow, there's a lot of people joining.
There's a lot of people joining. And as you play through the activity, we're going to be coming back to this activity at a few different points, and we can see how you're all getting on with the activity. At the start, we asked you all a question, and that question was, how did you get to school today? So we collected that data by asking you the question, and now we're going to analyze the results to try and understand what mode of transport is the most popular with all of you that are playing along with us this afternoon. So let's take a look at the data, Craig.
Yeah. So one way that we can visualize this data and understand it is put it onto a chart. So this pie chart is an example of data visualization. So rather than me or Daniel just reading, a list of what people have voted, we can show you the results on a chart like this, which makes it easier to understand. So what can we see here, Daniel?
So it looks to me that about 3/4 of all of you playing along today either walked or ran or rolled your way to school. And what's the next most popular? The next most popular is the grey segment, and that is by car. So it looks like sort of walking in the car are the most popular. At the other end, only one person is taking the bus to school, Craig.
Interesting. That is interesting. You think of more people would be getting the bus. But the thing is, Daniel, this is live data. So as people are playing the activity as well, those numbers will be changing and updating as well. We've been collecting some other data about you as well. We asked what different types of thing that you're doing to, basically what it is you do for the environment. And I'm getting some of your answers in right now. So David has mentioned that he recycles quite a lot as well. Ruby has said that she's from Birchgrove and she's going to start walking and not driving every day. I think if you're at a primary school, maybe you shouldn't be driving. I don't know if you can get your license for that yet, Ruby, but I'll take your word for it. Yeah, maybe leave the car. Don't get in the driver's seat.
I can see here that Ella has been walking as much as possible and planting seeds in their garden, and they try not to waste food, and they turn off lights when they're not in the room.
Grace as well said that she isn't looking to waste food that she's been given as well. And Nick Hill from Birchgrove has been doing a walk to school challenge, so that's really good to know too.
Oh, that's really cool. I can see that we've got loads of these answers coming in very quickly. Alice has been trying not to go in the car as often. Walk to school seems to be one of the really popular options. Let's see if we can find something else that's interesting. Reusing items before recycling wherever possible. That's what Oscar said, and Oscar's from Birchgrove Primary.
Brilliant. So before we move on, Daniel, before we explain our next part, maybe bring up the activity dashboard a little second and we can
There
see
we
how
go.
people are getting on here.
So I can see a lot of you are actually still just signing in and choosing an avatar. So hello to Marley, who's just joined. Aya, S, Oscar, Izin, Layla, you're just joining and creating an avatar. Hello, good afternoon to you.
If you have just joined us, don't worry, we're just getting started. Everybody's going to be kept at the same point in the activity, so you're not going to fall behind. But let me tell you, Daniel, tell us a bit about what the first thing it is people are going to be working through.
Yeah, so I can see some of you got to this point and some of you are just getting there, so that's totally fine. We'll have plenty of time for you to work through the activity at your own pace. So the first part of our investigation is to work out how much electricity do we need to supply to your school? How much electricity does your school use every day or every year? Now, we could get that data in a few different ways. You could look at the electricity meter, or you could even ask your head teacher to show you the electricity bill. And that'd be one way that you could find out the amount of electricity used
good luck
at
with
your
that.
school. You never know. But that would take too long. You might not even be given the data that you want. But as data scientists, we can learn how to work with data sets that will tell us what it is that we need to know. Now, we did a bit of research into how much electricity schools use, and it turns out that most schools use a really similar amount of electricity, at least within the UK. And there's data sets available with really detailed information on electricity usage.
So let's use smart meter data to give us an idea of how much electricity a typical school might use every year. So the data that you're using today is real data that is being collected by someone else. So it's been collected by Dundee Council and it's been shared so other people can use it. So basically they set up electricity meters in every school in Dundee and they recorded how much electricity was used every hour for a whole year. And they put all that data into a structured format. So in this case, it's a spreadsheet and they put it online for anyone to download it and use it. And that's the real life data that you're using right now. And because that data is available for anyone to use, it's called an open data set. So Daniel, why is it better to use an open data set rather than all of us trying to work out how much each school would typically use in a year?
Yeah, it's a good question. I think the main reason in this case that it's a good idea to use a data set is to save us time. You know, if you were going out and buying equipment and installing it and setting up, you'd have to leave it there for a whole year to count how much electricity was being used on that meter before you could do anything with that data. We want to know now, and we want to know how much. We can't wait a year. We need to do this before 3 o'clock. So, you know, by using open data, as long as that data is high quality and it's been recorded correctly, which, you know, it should be because it's from this open data set that lots of people are using, it can be reused by loads of different people to answer different questions. So for example, this data set here that Craig was talking about, these electricity meters in schools, they also get used by people like electrical engineers who are planning new schools to give them an idea of how much electricity they're going to need to provide that school with. They need to know how big a substation to build, and they need to know how large the cables need to be, how much current do they need to take. Now, Craig, I can see quite a lot of people have been looking at the data set. They've been opening it up and they've been taking a look at the graph to see how much electricity gets used every day. I think it'd be a good idea if we bring that up just now and take a look at it.
Sounds good to me. Let's have a look.
Let's have a look.
So what is this that we're looking at here? Well, this is a chart that is showing us the electricity used at Braveview Academy. So this is the real data that we're talking about here. And you can see that it's clearly going up and down. Like it looks as if on certain days of the week, it's higher than other days of the week. So as data scientists, we need to be able to analyze this data, try and get an understanding of why it might be doing this, what's going on here. So Daniel, the question here was, why is it higher during the week and yet it's being used less at the weekend? So the good news is we've got some of our participants here have started answering this question. So Thomas has suggested that he's seen that every Saturday and Sunday the energy used is much lower, and that's true. I can see that as well. Connor has mentioned that they could be off
on the weekends, so the school isn't running at the weekend. So that's probably a good reason as well.
Yeah, and TJ, who's at Laird's has said because there's no one there, and yeah, there might be a janitor or two, but there's no pupils there using, no teachers, so the computers aren't going to be on, the projectors aren't going to be on, the lights aren't going to be on. I guess the kitchen doesn't need to make food either. So yeah, I guess less electricity.
Kate has suggested that they don't need to maybe keep the rooms lit at the weekend because the staff aren't there as well. Yeah. Ori and TJ have both identified that there's no one there as well. I think we've got a couple more answers here. I'm just going to check. It seems like we're all coming to the same sort of consensus here.
Yeah, Oscar has said nobody in school. Lucas said there isn't much people going there at the weekend. I think that's true.
Yeah.
Most schools, yeah.
Yeah, these all sound like good answers to me, Daniel. I think we've interpreted that data quite well. Maybe we should look at it from a wider point of view as well. I don't know if you have.
We can take a look at the data and we can zoom out a bit. So let's zoom out, and rather than looking at just November and December there, let's look at it from July all the way through to December. Now, Craig, I can see it's doing the bit. So we were looking at it right at the end of this graph, but looking further on, it seems it's quite flat and quite low all the way up until mid-August. And then it's really busy. We can see the sort of like the pupils are in, and then it goes quite low again in October, and then all the pupils are back for another couple of months, and then it goes quite low again towards the end of December. What do you think's going on there?
Well, that's another pattern that we can spot, like just in my own experience of having been to school as well. What happens in October? What happens in December? What happens over the summer months? You're on holiday. The schools aren't on, so you can really see that clearly in the graph there, Daniel, as well. Look how big the dip is when it gets to October. So that shows me that during the school holidays we use a lot less electricity. Can I float an idea, Daniel? Maybe schools should be on holidays more often. Maybe that's one way we could reduce the carbon footprint.
Well, there's definitely less electricity being used, isn't there? And it's interesting to see that actually. I'm going to put the graph back again. The amount of electricity used at the weekend and the amount of electricity being used during a holiday is really similar, which I find quite interesting. So I suppose that makes we can be quite clear that, okay, that definitely is the school holidays. So even if I didn't know the term dates for this school, I guess we could just have worked it out by looking at when the electricity usage drops. Well, the school must be closed that day.
It's brilliant. How's our activity dashboard doing, Daniel?
Yeah, let's have a look here. So I can see that S has plotted a graph. I guess that's the graphs we were just looking at there. Sophia's been answering questions. You've got the answer right. Brilliant. Well done.
This is brilliant as well. Dylan, thank you for answering your question as well. Wardy Primary School.
India's just worked out how much electricity gets used on a typical school day. And that's a really important number because we're going to use that number throughout the rest of the activity to work out how much electricity it is that we need to be able to supply the school with. So that's a really important number. So well done for working that out.
And I saw Poppy and Ruby had also worked out when the energy was dropping during the October holidays as well. So that's good that you're working on this together. You're working in pairs, some of you as well, to work through this. I think that's why some of you are completing it so fast. Nothing like a bit of, I know about pair programming, Daniel, when it comes to computing, but do you get paired data science work, I suppose?
I think you do. Yeah.
Extreme data science.
Yeah, data scientists don't work in isolation. They don't work on their own. They need to work with other teams. They need to speak to the people who created the data. I need to work really closely with the people that have questions that need answered. Otherwise, there's a risk they might not answer the question properly, or they might not be using the data in the right way. So yeah, I suppose data scientists do work together a lot.
I'm thinking, Daniel, we should move on to the next phase of the activity now. What do you think?
Yeah, I agree. I think we'll move on to the next phase because I think the last few question of this phase is looking at the plot and identifying the dates of those holidays. So now that we've used that open data set from Dundee Council to get an estimate of how much electricity a school just like your one uses, we're going to think a bit about where that electricity comes from. Your school probably gets its electricity from the grid, and the grid is a massive network of power cables that link the country together. So houses, buildings, factories, shopping centres and power stations are all connected to the grid. And the grid is powered by lots of different sources of electricity, things like wind, gas, coal, nuclear and solar energy. Now, this is open data too. We can actually have a look and see, well, where is the electricity coming from right now? So I'm going to bring up the energy mix, as it gets called, and this is live data. This is a real dashboard, and these gauges show the proportion of electricity coming from different sources.
So I can see at the top left, Daniel, that pink gauge. That means that there's, quite a bit of wind power in the UK at the moment. And actually, looking out my window right now in Glasgow, I can see that might be true as well. So about 23% of the energy is coming from wind. But we've also got gas. So gas there is making up a large amount of the electricity at the moment. Is that quite typical for what you would see in the UK, Daniel?
Yeah, so gas power stations are one of the main ways that the UK gets its electricity. And that's because it's easy to turn it up and easy to turn it down to kind of pair up with the renewables. But by burning gas to get electricity, that creates CO2 and other greenhouse gases. And that's a problem because we need to reduce the amount of carbon that we're putting into the atmosphere because that's causing global warming. So we want to reduce the amount of gas and coal that we're burning to create electricity. And I'm looking at that big number in the top left, Greg. It says 47%. So 47% of the electricity that you're using right now, that we're all using, this is for the UK as a whole, by the way, is coming from what's called low carbon sources. So that's things like renewable energy and nuclear energy, because they don't emit any CO2 as they generate electricity.
So this is interesting, and this is live data, and it's also public data. So this isn't something that me and Daniel have special access to. If you're interested in how much energy you're getting at the moment, well, how that energy is being generated across the UK, you can look up the same chart as this as well. We'll put that on our website for you so you can look at those live numbers too.
Yeah, absolutely.
And it would depend on where you are in the country as well, wouldn't it?
Yeah, it really does depend on where you are because, different bits of the country might have more wind turbines than other parts, and other parts of the country are maybe more dependent on coal and gas. And again, we've got another open data set that we can take a look at that's going to tell us where the electricity is the cleanest and where it's what we call the sort of the dirtiest. So let's have a look at that list there. So in fact, Craig, look, this has gone down actually since I last checked. So in the north of Scotland, so anywhere north of Perth, actually it's completely renewable powered, 100% renewables, and that's because of all that wind energy that we've got. It's quite a windy day. The wind turbines are providing all of the electricity for the north of Scotland. And as we move down, we can see more carbon dioxide is involved in the creation of electricity. So looking at the areas at the bottom, the East Midlands, I know they have a big coal power station there. So there's more carbon dioxide being created. And at the very bottom, we've got South Wales. So if you were using electricity in South Wales, that would be emitting a lot more CO2 versus if you were using electricity in the north or even the south of Scotland.
This is really interesting, and Daniel and I love looking at data like this and trying to understand it as well. Let's think about it more about like what you're doing as well, because that electricity you're using in your school is going to have a carbon footprint as well. And one way that we can cut that carbon footprint associated with the electricity used is to use renewable energy to have some sort of renewable source of energy at your school. So I'm talking about something like a solar panel or a wind turbine. So we asked you as part of the activity if your school generates electricity. So does your school have a solar panel? Does it have a wind turbine? Daniel, we've not looked at a chart for at least 15 seconds. I feel like we should bring one up again.
Yeah, let's bring another chart up. So this question here was, we asked you, does your school generate any of its own electricity? So yeah, does it have a wind turbine or solar panels? And 6 of you have said that your school does have a wind turbine or solar panels. I can see that 47 people said that your school doesn't have any of these of your own. You know it doesn't. But it looks like, I don't know, what's that, about 2/3 of people don't know if their school generates their own electricity. And I think that's probably quite typical, because if it's solar panels on the roof, how you can't see them unless you get on the
Unless
roof.
you climb on the roof.
Unless you climb on the roof, which you probably shouldn't do. So
Yeah, ask your teacher if they can go onto the roof to
Yeah.
check and see if there's any solar panels. No, don't do that.
yeah, maybe get a drone instead.
Much better idea, Daniel. Much safer. I can see, Daniel, that people are working through this activity now. They're researching about solar panels. And one of the types of solar panel they're looking at is photovoltaic solar panels. I would say that if you're answering that question, watch your spelling very carefully on that, because we're seeing quite a few people trying to answer it, but misspelling that as their answer. What's the best advice you would give them, Daniel?
Copy and paste. So, if you know what the answer is for that question, where it's asking you to choose what type of solar panel, copy and paste it in, and then it'll accept it. So yeah, if you keep getting this answer isn't looking right, double check your spelling. That's what it might be.
So in this phase of the investigation, you're looking at solar energy. So the question that you're trying to answer is, how much sunlight do you get at your school's location? So that's a really important question for renewable energy. And we need to know how much light there is so that we can tell how much of it can be turned into electricity. So we're going to need sunlight data. In other words, we need to know how much solar radiation your school gets. Now, you could measure this. So think about the technology that you would need to do this. What you could do is you could go stand outside right now with a light meter, and you could record how much light there is right now. But you would have to do that over a whole day, all week, and all year. That is far too long just to be standing outside. What could we do, Daniel? What is a better way that we could use technology and data science to help us?
We could use another data set. So NASA collects loads of data about planet Earth using their satellites, and they've got a data set that will tell us how much light falls on any location on the planet across a whole year. So if we send NASA the latitude and the longitude, so the coordinates of your school, they're going to respond with the data that we need. So we need to know the latitude and the longitude of your school first before we can use this data set, before we can get the numbers for your school. So what we've done to let you do that is we've put a map in the activity so you can find the coordinates, the latitude and the longitude for your school. So what you need to do first is find your school on the map. So you could either type in the village name or the town or the city where your school is in the top right, and then you could zoom in until you find your school. Or if you know where it is, you could just zoom straight in. And once you've found your school on the map, or you've even just found the town that your school's in, click on the building and it will drop a pin and it will show the coordinates at the bottom of the screen, ready for you to submit them.
I can see that Eva and Ella and Lydia, they've been pinpointing their school on the map. That's brilliant as well. Well done to Leon, who's also working that out as well. And Harvey and Judy as well. Well done, Judy, for working out that you need to know the latitude and longitude.
Yeah, I can see that Sophia's just found the latitude and longitude, so they've just used the map. Recently, you are analysing a chart, so you've already requested the data. Brilliant work, you're steaming ahead. Sarah, you've been analysing that data as well. Tessa and Amelia, you've got the data, you've requested it from NASA. Dakota, you found the latitude and longitude of your school. Brilliant, good work.
And this is real data. Like, we want to point this out. This is actually coming from NASA. This is information that they've collected. And to access that data, we're using an API. Well, you're using one. So an API is a way that a computer programmer can access data sets that belong to someone else. So to use it, we need to form a formal request, and NASA will reply with a response that includes that data that we need. So we need to tell them the exact location that we want to know the sunlight data for. So that's your coordinates of your school. And we need to tell them that the year that we're interested in. If we give that request correctly in the right format, then NASA's servers will respond with the information that we need. Now, You could do this just by emailing NASA. So you could send them an email and say, could you send me the data for this, blah, 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 blah. But that might take a bit of time. It might take a day or so before anyone even responded to you. But by doing it programmatically using technology, using an API, we should be able to get a response back from NASA in under a second. In fact, I can see that the schools that are taking part in this activity right now, you are getting those responses back from NASA servers, and I'm pleased to say that you're getting them within a few seconds. So that's brilliant.
Yeah, and do you know what? Now would be a really good time for us to thank NASA's Langley Research Centre. They've given us special permission and special privileges to use all of this data for this activity today because it's linked to COP26. So thanks to Langley for that.
Thanks, NASA.
Thanks, NASA. I can see that loads of you have already sent in your requests using that API that we were just talking about, Craig. So I'm going to bring up a few of the
can you show me some, because I'm
plots.
interested
Yes.
here.
So here we go. Here's one. Now this is Craighead Primary School, and this is the amount of sunlight that arrives on a 1 by 1 meter square of land at their school's location. So this is the real data for 2020.
It's brilliant. Thank you for people taking part at Craighead Primary School. Let's see how we're doing. So okay, so I can see here that the higher the line is, the more light that they are getting as well. So I can see that May seems to be the month that Craighead Primary School are getting the most light as well, or it's certainly it's reaching their school. That's the amount of solar radiation as well. I can see that there by the dot on the chart. I think that's kind of what I would expect, because it's a springtime, but initially I would have thought, Daniel, that June or July or August would have been the months with the most amount of light. Why is May sort of got a higher amount? What do we think?
Yeah, so I think it's a bit higher in May because May tends to be a drier, a less cloudy month on average than June or July tend to be. So although we maybe get some more daylight hours in June than we do in May, it tends to be cloudier. And this API, this data set from NASA, it even takes into account the weather in the clouds. So it really is the light that actually hits the ground at your school. So yeah, it takes into account loads of different things.
And I think when I think about it as well, like often you do get, sunnier, brighter days in months that May, June, than you sometimes do in July and August as well. So this is really interesting being able to see this data here. But let's look at another primary school. So this is Wollaston Primary. And while their graph is quite similar as well, so it looks like their top month for light is May as well, and then it goes down for the rest of the year. That's the kind of peak there as well. And that's quite similar. And do you know what? I would expect that because Wollaston is not that far from Craighead in terms of the size of the Earth. Realistically, they're quite close to each other in terms of the size of the Earth. So they should have that sort of similar pattern as well. So it seems like that the data that you're getting there and we're graphing is consistent with what I would be thinking. So thank you, Wollaston Primary School, for analysing that data as well.
Let's take a look at one more school just now, and this is a school in a different country. So let's see if it's a bit more different. So this is Highfield Secondary School in Jakarta, and one of the pupils there has just requested this graph from NASA. Now, just before we look at it a bit more detail, Craig, I've noticed that the scale on the left-hand side, it starts at 4. And that's kind of what we were getting in the sort of the summer months in the Scottish schools. So even this kind of the month with the least solar activity in Indonesia is about the same as our summer.
Daniel, that doesn't surprise me as well. Like Indonesia, very close to the equator as well. And I don't know, but based on the shape of this graph, like I'm looking at this, Daniel, and they've got the most light in August, September, October. Is that when their summer is? Is that are they in the southern hemisphere? Or are they the opposite of us?
Yeah,
must be very close.
Yeah, so they're just in the southern hemisphere, and actually that is when they tend to get their summer. So they don't have 4 seasons there; they have fewer. But yeah, that is exactly what it is. We can see where their seasons are looking at just this data here.
This is brilliant. So Thank you for submitting those API requests. I can see that quite a lot of you are visualizing that data just now. Who's on the activity board?
Who's on the
Aberdeen
activity?
Grammar School are taking part. Birch Grove as well. David's been analysing the chart as well.
Cara and Louise, or Louisa, you've just requested the data from NASA, so you'll be able to plot that in just a second.
And H now has the data they need. Brilliant.
Oh, do you know what? H is now analysing the chart, Craig.
Even better.
Even better. M, you've just requested data from NASA.
I've been looking, Daniel, at some more responses from the question that we asked earlier about what things people are doing.
Yeah.
Alice from Balmoldy is using the car less, and the Primary 7 class from Wardy Primary School are reusing items before recycling when possible as well. So I suppose some of these things that we're talking about there are things that you can do on an individual level. But what's quite exciting here, Daniel, is we're not just thinking about like what you could do personally. You're thinking about how can we use data sets to affect a much bigger thing than that as well.
Yeah, so we can all make a difference by making these choices, but there's a lot of things that, you know, we're not in control of really as individuals. Whereas, you know, if we work together and if we look at these bigger changes, where do we get our electricity from? That could make a huge impact. That could bring us a good distance forward in the sort of the targets that we need to hit to kind of hit net zero as soon as possible. So yeah, definitely it's great to hear what you're all doing individually, and I think this kind of activity kind of shows when you go up a level the difference we're going to make, and we're going to actually explore the amount of difference that could make as we get towards the end of the activity in just a while.
I think we're ready to move on, Daniel, to the next phase.
Yep, I think we are as well. So where have we got to so far? Well, you've now got the data for how much light or how much solar radiation falls on each square meter of ground at your school. But we want to know how much of that solar radiation can be converted into electricity by a solar panel. Now, solar panels can't convert all of the light into electricity. So we're going to need to do some sums to work out how much electricity could actually be generated for every square meter of solar panels at your school. I think what we'll do is we'll give you 30 seconds or a minute to kind of work through those questions. So I think, Craig, maybe we could go back and look at the poll question from earlier about how you travelled to school.
How about I tell you a bit about the Data Education in Schools project?
So, why not? Go for it.
This project's part of the Data Education in Schools project, and we're also presenting this workshop with Digital World as part of Skills Development Scotland. Now, the Data Education Schools project's part of the Edinburgh and South East Scotland City Region Dual Skills programme, which is funded by the Scottish Government. But the main point is that you can use data science skills to work in all sorts of different areas. So we're talking about it in renewables sector today, but we're talking that you could be working in healthcare, agriculture, finance, tourism, the public sector, or the creative industries. And data skills are important across all areas of science and technology. So maybe you want to work in physics or chemistry or biology or computing science, then having data skills will be really useful to work in those areas. And yeah, there's lots of job opportunities in this area in Scotland. So according to Skills Development Scotland, there are over 3,000 data scientists currently employed in Scotland. And the average salary for someone working in this area is about £52,000 per year. That's about double the average salary of other jobs in Scotland. So it's a really well-paid area to work into. And after today's activity, you can find out more about the jobs in this area by looking at the Digital World website and looking at dataschools.education, and you can join their newsletter as well.
Great.
How was that, Daniel?
Yeah, that's a really good picture.
Just came to me.
Yeah. Well, it's important to say who it is that is supporting and how this has been created. I've been having a look at the activity feed to see how you're getting on. And what you've been doing is you've been working out Well, looking into these solar panels and looking at what is the efficiency of a modern solar panel, and what you found is that the efficiency of the solar panels that are available to us right now is around about 20%. So in other words, about a fifth of the solar radiation that arrives at your school can be converted into electricity that could be used to power your school.
That seems quite low, doesn't it? Like in my head, I would have thought like a solar panel, like the top of the range one, I don't know, would be about 80% efficient, 90. It's only 20.
It's only 20, however, there is a lot of sunlight. Like it's a lot of energy that's coming in, and it's free, it's never going to run out, and it's just there, it's just available, it's very consistent. So when you look at it that way, it's not so bad. But just looking at the efficiency in particular, that 20% figure, well, actually, there's solar panels in labs and in development which are much higher than that. There's actually solar panels that have been created which are 40 or 50% efficient, but we just don't have the technology and the manufacturing facilities to manufacture them yet. So really, if we had more people that worked in this area, if we had more engineers and physicists and data scientists that would be able to kind of solve these problems, we could have cheaper and more efficient solar panels in the near future. So, you know, that number is going to keep going up and up and up. But actually at 20%, there's still a lot of energy that we can harvest for basically for free once we've installed them.
Daniel, we're almost there. I can see that some people are already calculating the size of the solar array for their school. So how big are they going to make it? Now, if you were doing this manually and you wanted to work out, you know, how big an area, say you wanted to put it over your school roof, you would have to, like, how would you go about measuring that normally? You would have to, like, climb up onto the roof with a trundle wheel, and you'd have to walk along the very edge and measure it all out very slowly. But we're technologists, we can use geographic information systems to help us with that. So in this activity that we've made, there's another map. And what you can do with that map is really interesting. You can draw a shape around the roof of your school, and that will tell you the area, the size of the solar panel that you can make as well. So what you're going to do is click on the edges of your school to draw that, to sort of mark that out. And then the geographic information system will calculate the area, the size of that solar panel.
Yeah, maybe there's a flat bit or a whole building that you'd like to cover in solar panels, where you can use that tool in the map to draw that out. And that map's really cool. It's even got a data layer that shows the buildings and the shapes of the buildings. So that's like a data set in a data set. And then we'll get even more data out of it by combining the two of them together. Once you've got that area, we've got one final calculation for you to do. And that's going to answer the question of how much electricity could be generated by a solar panel on the roof of your school. Because you now know how much electricity can be generated by a panel that's a meter by a meter at your school. You just worked that out a few minutes ago, and you'll be identifying an area for the solar panels right now. And I can see loads of you are doing that right now, and a lot of you are just about to get there, and some of you have already done it. But that number, you're going to multiply it by the amount that could be generated, and that's going to give us our total. And do you know, I can see these numbers starting to come in, and it's really, really impressive.
That's excellent. So yeah, do that calculation. You're going to multiply the amount of electricity for 1 by 1 meter square and times it by the total area. That will give us the total amount. Daniel, are we getting in some submissions? I would like to be able to see how much electricity is going to be generated by solar panels on school roofs.
Yeah.
I'm interested.
Well, we've got the numbers for Laura at Edinburgh Uni. We've got the numbers for Katie and Abby at Balmoildy. We've got the numbers for Luke at Birch Grove. So that's 3 different sort of educational institutions so far. I can see there's some more just coming in. Aled at Birch Grove, yep. You've just multiplied them together. Brilliant, good jobs.
Laresland Primary as well.
Judy's just measured an area for the solar panel. I can see a lot of people measuring the roof using that map.
B has plugged in the numbers. Reese and Lily are doing well. They've answered the question correctly as well. Hello to you.
Sophia's just calculated the amount of electricity that could be generated on a 1 by 1 square meter bit. So they've multiplied the efficiency by the amount of incoming solar radiation. So the next step for Sophia is going to be to measure that area of the school roof.
So we plugged in the numbers, Daniel. Let's see some of these results.
Yeah,
I'm
let's
keen
have a
to
look
see.
at some of the stats that are already through. So here are the numbers for St. Joseph's Primary in steps. So big shout out to whoever it was at steps that whose numbers we've taken here. So let's see. So you calculated that the solar panels on your school could generate 225,000 kilowatt hours of electricity over a year. Well, what does that mean, Craig? What does that mean?
Daniel, that means that would be enough to charge nearly 19 million iPhones in a year. That's a lot of electricity.
Yeah. Imagine having
And
that
look at
many
that.
iPhones. Would it be bigger than
I
the school?
know.
I don't know.
I feel bad enough having to charge up my phone once a day, and it's like, well, don't worry, you could charge it up 19 million times. So it's also enough to power 27 computing classrooms for a year, or drive an electric car from Edinburgh to Dundee over 15,000 times. That's brilliant.
Let's take a look at another one. So this one is Highfield Secondary School in Jakarta, and
So friends at Jakarta again.
105 computing classrooms for a year. So that's a bit more. I wonder if that's because the school's maybe a little bit larger, because it's a secondary school rather than a primary school. And I wonder as well, there's just a bit more solar energy available in Indonesia.
I think the solar energy must play a big part in it as well. We saw that graph earlier. It's not just the size of the school, it must be the amount of light they're getting as well.
So if you could move that electricity from Indonesia to Edinburgh, you could drive to Dundee 59,000 times.
So, transferring the batteries
Yeah.
on the back of a lorry, maybe?
And let's have a look at one more. So this is the numbers for St Paul's Academy in Dundee. And they've worked out that they could power 27,362 light bulbs continuously 24/7 for a year. And those are bright light bulbs. They're 10-watt LED light bulbs. So they're like the brightest ones that you can really buy.
This is brilliant, Daniel. This is brilliant. We're getting so many results in here, and it just shows you that the solar energy potential, even in Scotland, because I think a lot of people would think, Scotland isn't very sunny. This is not something that we could be doing here. You might automatically think wind power, but actually it shows you that, if it was cheaper to do these sort of things, if we had more efficient panels, perhaps this is just one part in the puzzle that is going to help us reduce our reliance on things like fossil fuels.
Craig, I've been looking at the numbers coming in, and we've got results from 20 different schools. Yep, the 20th one just came in. So if all of those schools installed their solar panels that they've just described, so we've taken one pupil from each school, and we've worked out collectively that you could power 69,406 light bulbs for a year. Now, to put that into context, I can see that the Blackpool Tower has... That's over 12 Blackpool Towers worth of light bulbs, which is the international standard.
The international standard for measuring the number of light bulbs, yeah. So what was that number again?
69,406 light bulbs. So I've got a graphic that will illustrate
I was going to say, let me type that in for you, Daniel.
Okay.
We can use our tool to do that. So 69,406. Okay, to give you an idea of how many that is, that should be ready, Daniel.
Oh, thanks, Greg.
This is a bit of data visualization for you here.
Yeah, so while the light bulbs are flying past, and I hope you're counting, in terms of the amount of carbon dioxide that would save if all of your 20 schools had these solar panels that you've just designed, that would save 1.1 million tons of carbon dioxide every single year. So that would be a huge amount of carbon not being emitted by generating that electricity with a clean, renewable source of electricity. And we now know it's possible. You know that's the real numbers for the amount of light at your school, and that's the real size of your roof. So, this is all feasible stuff.
This is brilliant. And Daniel, I think as we move people on now as well, we should thank people for being part of this activity today and helping us generate these 69,000 light bulbs too.
Yeah, thank you very much for, being part of our data science team today. We definitely couldn't have done it without your help. You've given us the data for 20 different schools, and I hope this has got you thinking about how we can use data to reduce the carbon footprint of your school or of other buildings as well. Now, there's one last task that we need you to do, and it is an important one. We need you to answer a few questions about today's event and tell us what you thought.
So click continue and answer the questions that come up on your screen. I think we've seen enough light bulbs now, Daniel.
I think the light bulbs are about to finish. There we go. So we're going to be running another live lesson later this month in a couple of weeks with Skills Development Scotland and also Historic Environment Scotland. And this activity is called Defend Stirling Castle, where we'll look at what castles can teach us about cyber security. So I hope you'll join us for that activity too.
I'm really looking forward to that one, Daniel. Do you think cybersecurity, they might give me a shield or a sword or something?
I'm sure we can get some props.
I'll need to ask Kirsten.
Yeah. So we are also on YouTube today. So, feel free to like the video. That'll help us with our stats. And also, if you subscribe to the channel, that means you'll see all of our future activities, lessons, and live streams as they go out.
If you're a teacher or a parent, you can tweet us a photo of your report cards from the activity. You can tweet it to us at digitalworldhq and at data_schools using the hashtags COP26 and Data Skills Live. We've had so much fun plugging in the numbers with you today. So why don't you try out one of our other data science activities? Maybe you could code your own data selfie, or you could try defending endangered rhinos with data science. You can do all that by going to our website, cyberskillslive.com.
Thank you very much for joining us today. I hope you enjoyed it. I hope you learned something. And I hope that data science was fun and exciting for you as it was for Craig and I creating this activity. But for now, it's bye from Sunny, and I hear that she does say goodbye to you. And it's also goodbye from Craig.
Bye-bye.
And it's bye from me as well. See you next time.